In this video, I'm going to make a short overview of all the tools that you can use from the natural language processing form. From this form, you can perform a lot of different types of analysis on text files. While in the Cactus form, all the information extraction process is performed by hand, here are available a lot of different tools to perform this kind of analysis automatically, plus some tools to visualize and interpret your data. The computer science field that deals with this kind of tasks is called natural language processing. In the humanities, the use of these tools has often been labeled as distant reading, as opposed to the close reading a humanist typically approaches a text. The tools for preparing the files to be later processed are mostly included under the label Document Tools here. From there, you can choose to handle documents. This entry allows you to perform different operations on files, for example, listing, copying, moving files in the default document folder, or you can also name or merge files in a user-selected folder. You can also convert, merge, or split documents. You can convert documents from doc, docx, PDF, RTF format to text format, or merge multiple documents into a single one, or split a document that you have merged previously. You can also convert text documents into doc, or you can run the spelling checker. That is a tool that aims to correct the spelling errors in an input file without any human intervention. It does so by using a set of spelling mistakes detected in Wikipedia and by using an internal dictionary. External dictionaries are also supported. You can also create a document summary automatically, selecting the most relevant sentences in it. You can also add primary complex IDs and identifiers to file names. These documents need, of course, to be imported in PCAs previously and to be cross-referenced to at least one primary complex. This procedure allows you to prepare the document file names to be later processed with other tools. You can also find the documents that are not related to others in different subfolders. This tool takes and input a folder with multiple subfolders, and then for each subfolder compares all the articles inside that and finds the articles that are not about the same topics, then outputs a list in each of these subfolders. You can also find duplicate documents in a folder. This tool uses Lucene, that is an information retrieval tool, to compare documents and discover duplicates automatically. Or you can print the dependency tree for each sentence in a text file using dependency and Stanford Core NLP. This tool takes and input a text document, processes it with a Stanford Core NLP toolkit, and then outputs for each sentence in the document a picture of the dependency relations between tokens in a sentence. The Stanford Core NLP is a set of natural language processing tools that allow you to analyze text automatically. Some of the tasks performed by the Stanford Core NLP are tokenization, that is the separation of the different words in the text, path-of-speech tagging, that associates a label to each token and categorizes it as a noun, adjective, and so on, lemmatization, that extracts the lemma from each term in the text. For example, verbs like went or going are all converted to go, that is the lemma corresponding to this verb. You can also see the role of each token in the sentence in relation to other words, that is dependency parsing, and a lot more. One of the great advantages of running Core NLP and obtaining the kernel table is getting a structured version of a corpus that you want to analyze. In fact, when you run the Stanford Core NLP toolkit, you get various information for each word in the text, as I said before. The NLP form has also a number of different types of searches that operate on the kernel table, on separate text files, or on a merged text file. Let's have a quick look at these. We have a simple word search within a doc, docx, RTF, or TXT document that allows you to search for a string basically in a document. A keyword in context search based on a word co-occurrence user table that allows you to look for a specific word and all the words that co-occur with it according to a previously computed word co-occurrences user table. The word co-occurrences user table is created using the kernel table. The table has a variable number of fields, and the first two contains the two co-occurring words, and the other fields contain the frequency at which the two words co-occur at the selected relative position. We have this other function, the keyword in context search, based on the word's dependency relation within a sentence of a kernel table, that allows you to look for all the words co-occurring with another one that you select, filtering them by their role in the sentence. For example, if you search a verb, you want to see the objects that co-occur with that verb, you can use this function to do that. You can also search for words that have a syntactic relation to a specific word in a CONOL table. The difference between the third and the fourth options is that in the fourth option you don't have the limitation of the range that you have used to compute the word co-occurrences user table, but you can look in the whole sentence using the CONOL table. The NLP form provides a number of different ways of visualizing text data so as to make more immediate any patterns in the data. To do so, you have to click on the label Visualization Tool, and you can choose, for example, the first option, Visualize Sentence Data, to plot the sentence length by sentence index. From a CONOL table, you get a graph in Excel that represents how the length of the sentence changes in a document, or you can get a dynamic sentence network that you can open in Gephi. That's a graph that shows you at once only the words that appear in each sentence in the document, and you can use the slide bar on Gephi to advance to the following sentence in the documents and see what words are still used and which chain. You can also choose to visualize word co-occurrences, and from this entry you'll be able to create a Gephi graph from a word co-occurrences user table. Or you can choose to visualize word clouds. There are several softwares in the web that you can use to create word clouds, and PCAs allows you to prepare the data for those software. You can choose to plot the data from a CONOL table or from a PCA's dictionary or from any text file. You can also display the frequency of the word co-occurrences for a specific word and create a radar chart. We can try that. We can select first the word co-occurrence user table that we're going to use and the word that we want to search. We also have to select the position that we want to use to create the radar chart. For example, if we want to visualize only words that appear right before or just after a certain word, we would choose a window size of 1. If we want to look for words that appear 2 words after the selected one, or 2 words before, we choose 2, and so on. For now, we just select sentence, so we'll get all the words that occur in the same sentence of the selected one. And here you can see all the words that appear together with the word Negro in the same sentence. The NLP form does not provide any sophisticated statistical tools. All you can do in PCAs is obtain simple frequency distribution of varied text features and visualize the results. To do so, you can click on Statistical or Frequency Tools, and from here you can compute the frequency of any of the CONOL table fields. You can display frequencies of the words in a word co-occurrences user table, or you can display frequencies of word co-occurrences for a specific word. So you search for a specific term and then get the frequencies of all the words that co-occur with that term and their frequencies. Or you can search for engrams in text files. This function outputs some useful statistics on the words in the analyzed document or documents, such as word frequencies or the most frequent engram frequencies. If you choose to analyze a set of articles that contain a date in their names, for example, files that follow PCA's file naming criteria, then you'll be able to group them by date and get the statistics for each engram that you searched. You can also look for a set of words for which you're interested in seeing their co-occurrences rate over time. You can use this tool for text in any language. We can also compute some sentence statistics on the CONOL table, and this function allows you to analyze a CONOL table and get some statistics regarding the sentences, such as the sentence length or the distribution of some given words among the sentences, and more. Given a set of documents, or just one on your corpus, you may want to get an idea of the broad topics discussed in the corpus. This type of automatic task is known as topic modeling. Suppose also that you have a few hundred newspaper articles and you would like to be able to sort them into different groups without having to read them all, and using a set of criteria, for example textual items found in the text such as location, date, individuals, or organization. This task is called text categorization. You may also want to get a general idea of how words in a corpus are used and which ones are more likely to be used in the same context. For this task, you can run Word2Vec on your corpus to analyze it and produce a network graph of the words' relations that appear most of the times together. The NLP form offers all these options under the topic modeling and text categorization label. You have two more buttons here, Open User Table and Text Analysis Software. From here, you can choose to open a kernel table, a kernel frequency table, a word coherence table, and so on. Or you can also run some text analysis software such as Ankong, Apache OpenLP. All the procedures that are run from this form use those two folders as the default input folder and output folder for their data.